13.4 is factoring trinomials where the leading coefficient is not 1. So we're just continuing what we've been doing in previous sections. So I'm going to use the Berry method. The first step always is to see if there's a greatest common factor. So can we take anything from a 3, a 10, and an 8 out? No, we can't. So what we're going to do is we're going to do A times C, which is 3 times -8 or -24. And so this means that I have to have one positive and one negative number. Now let's write down the factors of 24. 1 and 24, 2 and 12, 3 and 8, and 4 and 6. We need to find a combo of numbers that add up to -10. So this means that the bigger number has to be negative and the smaller number is positive. And so in the first case, we get -23. In the second one, we get -10, which is exactly what we're looking for. So that means 2 and -12 is my combo. We're going to set up our parentheses. We bring down the leading coefficient into both, and we split the x's. We've got +2 and -12. And the last step is to divide out whatever the binomials have in common. So in the first one, they only have a 1 in common, and in the second one, they have a 3 in common. So our final answer is 3x plus 2 and x minus 4. Let's go ahead and look at the second one. 8x squared plus 8x minus 6. So the first thing we can do is we can pull out a greatest common factor of 2. So I'm going to pull it out front, and what I have left over is 4x squared plus 4x minus 3. And we'll do the Berry method on that polynomial. So A times C is 4 times -3, which is -12. Again, because we got a negative number, one needs to be positive and one has to be negative. The factors of 12 are 1 and 12, 2 and 6, 3 and 4, and we want to get to a positive 4, which means that the bigger number is positive and the smaller number is negative. And so in the first case, we get positive 11. In the second case, we get positive 4, which is what we were looking for. And so we go ahead and bring that 2 down, and we set up our parentheses just like the last one. The 4 gets brought down into both, and we split the x's, and we have a -2 and a +6. The last step is to divide whatever they have in common. So in the first one, they have a 2 in common, and in the second one, they also have a 2 in common. And so our final answer is 2 times 2x minus 1 times 2x plus 3. Let's go ahead and try example number 3. We've got 20x squared minus 46x plus 24. There's definitely a greatest common factor we can pull out of this. We just got to figure out what it is. So let's break down 20 using prime factorization tree. That's 2 and 10 and that's 2 and 5. Let's break down 46. That's 2 and 23. And we've got 24. So that's 2 and 12. And that's 3 and 4. And we got 2 and 2. So then what do all of these things have in common? They've got a 2 in common. And that is it. So that means we can pull a 2 out front, and we're left with 10x squared minus 23x plus 12. Now we can go ahead and do the Berry method on the inside polynomial. We've got 10 times 12, which is 120. And because we got a positive number, that means we could have 2 positive numbers, or we could have 2 negative numbers. Now, since the middle term is negative, that means both of our terms need to be negative. So let's go ahead and write down the factors of 120. We've got 1 and 120. We've got 2 and 60. We've got 3 and 40. We've got 4 and 30. We've got 5 and 24. I'm going to write it next to the first column. We've got 6 and 20. We've got 8 and 15. And we've got 10 and 12. And so because these all had to be negative, we can figure out which combo gets us to negative 23. And so the negative 8 and the negative 15 give me negative 23. And so we just go ahead and copy and paste that 2 that we pulled out originally. Both of our parentheses are going to get a 10, and the x's get split. And we have a minus 8 and a minus 15. Now we just need to divide out whatever they have in common. So between 10 and 8, we can divide out a 2. And between 10 and 15, we can divide out a 5. So we get 2 times 5x minus 4 times 2x minus 3. And the last one. We've got 6x squared plus 15x plus 9. Always your first step is that greatest common factor, which in this case we can pull out a 3. And we're left with 2x squared plus 5x plus 3. And so let's go ahead and do the Berry method on the leftover polynomial. That's 2 times 3, which gives me 6. And because it's positive, it can either be 2 positive numbers or 2 negative. But because that middle term is a positive 5, that means we're going to be using the 2 positive numbers. Our factors of 6 are 1 and 6, and 2 and 3. And so the 2 and the 3 is going to get me to 5. And so the 2 gets brought down into both sets of parentheses and the x gets split. We have a +2 and a +3. And we need to divide out what they have in common. In the first one we can divide out a 2, and in the second one we can only divide out a 1. And so we still have that 3 up front, times x plus 1 times 2x plus 3.